So, as I say, we're going to want to be able to write code that can do that we can use multiple times. And one of the best habits to get into when you're learning to code in Python or really in any language is to wrap any code that produces a well-defined output from a well-defined input inside a function. So as you're learning Python and as you're developing different bits of code that do different jobs, I encourage you, whenever you have a small piece of code that accepts some inputs and produces some outputs, to wrap it in a function like this. A function is just a piece of code, the same as the code we've been writing so far, that takes different inputs when you call it, when you run it, and will return some well-defined output. So it's a nice way of encapsulating the commands you're writing into a little block of code that does a well-defined task. Functions are great because they allow you to build up much more complicated processing from very simple functions. The best way to achieve more complex tasks in Python and in coding in general is to write a bunch of simple functions that all build on each other and gradually build up the functionality of your code. So if you want to write some code to analyze a large data set, first write a function to do the analysis on one data point. Then write the function to use that on all your different data points. Maybe write another function to clean up the output and save it to a file. Build up your code function by function like this. We'll see some examples. So overall, this is how you define a function in Python. The keyword def is important. Then you give some function name. You'll notice I put an underscore in my function name here. You can't put spaces in your function name, but I do encourage you to have long descriptive function names so you remember what they do. So def, function name, and then in the brackets you have some input parameters, or some arguments as we call them. So this takes a parameter 1, comma, and a parameter 2. Then we have this colon, new line indentation, and there, indented under the function definition, is where we write the Python code that we actually want our function to do. And then usually our functions will end with a return, which the keyword return will then, after it, tell you which variable is the output from our function. So the inputs are given after the function name in brackets, and the outputs will be after this return statement. They don't always have to be outputs or even inputs, but the format will look like this, and usually there are inputs in brackets and outputs after the word return. So let's write our first function. I'm going to do def, and then I'm going to give the function name my first function. You can call it whatever you want. Then open some brackets, and this is where we give the inputs to the function. So my function is just going to take one input, and I'm going to call my input my parameter. We don't know anything about the type of this input yet or what data it contains, but we know we have one input. I then have a colon, a new line, and an indentation. And what do I want my function to actually do? Well, first I want it to print that I am running my first function. We've seen a bunch of these print statements before, so we know that that's going to show that text to the screen. And then the final thing I want my function to do is return some output variable. And what do I want my output to be? Well, I want it to be my parameter multiplied by 3. So my parameter is my input variable, and my output variable is going to be that input variable multiplied by 3. So this is a very basic function. When you hit enter after defining the function, no results will be printed to the screen. Nothing will be run. So we've done this, we've defined the function, colon, new line indentation, we've done the print statement, we've done the return my parameter. We hit enter one more time on this blank line, and all that happens is we're returned back to the terminal with our arrows at the start of the line. But what's actually changed is that now this function is defined and we can use it. So to actually call the function and run the function, we type my first function, and then in brackets we give the inputs that we want to have this time we run the function. So my first function, and in brackets I'm going to put 2, and what will happen when I hit enter is it will print running my first function, and then it will print the output, which is going to be 2 multiplied by 3, so 6 is printed to the screen. So when you have the function defined, you can run it a bunch of times with different inputs without redefining the function. So I encourage you to run my first function, give it a bunch of different inputs, and see that whatever you pass it as inputs will be returned multiplied by 3. Now there are two different ways of running a function. If you run the function on a line on its own, with no equal sign on the line, the output, or whatever is returned from the function, will just be printed to the screen. So that's what happened this time. I typed my first function, I gave it the input 2, and the returned value, the 2 multiplied by 3, was just printed to the screen. If, however, you run the function on a line with an equal sign, and a variable name on the left of that equal sign, whatever the output of the function is, whatever is returned, will be stored in that variable instead, rather than printed to the screen. So on this line, I've done my number equals the result of running my first function with some input, and I still see the running my first function printed to the screen, but you'll notice there is no number printed, so that big number multiplied by 3 is not shown on the screen. However, it is stored in the myNumber variable. So if I then check the value that my number has, I see that it contains this number multiplied by 3. So if you call a function without an equal sign, the output is going to be printed to the screen. If you call a function with a variable on the left-hand side of an equal sign and the function call on the right, the output will be suppressed and the returned value will be stored in that variable on the left of the equal sign. So let's now write a more useful function. And first I want to introduce the concept of pseudocode, which is when you plan out how you're going to write your code before you write it. So it's tempting when you open Python to write a function to achieve a task to just open the environment and start typing. However, you often find that you get halfway through your function definition or halfway through your algorithm and you realize you've done something wrong, or you've not thought about the problem entirely, you've not thought about how to solve it, and you have to start again. So it's a good habit to get into to when you approach a problem that you want to solve with a piece of code, to first sketch out the idea as pseudocode. And the way I think of this is how you would talk to your computer if you could talk to it in simple commands. So if you want to achieve some code that calculates the GC content of a sequence, you might first take that sequence as an input. You might count how many times G occurs, how many times C occurs, add up the G's and the C's, and divide that sum by the total length of the sequence and return that as my result. So now I've thought about the algorithm that I'm going to take to solve my problem. I have some line-by-line instructions that if I could talk to the computer in plain English, I might make it do. And now I'm going to convert those simple instructions into lines of code, knowing that if I do it right, I should solve the problem. So it's a good idea to sort of sketch out the problem like this first before you type any Python code, in any language, to be honest. Okay, so this is what I'm trying to achieve, and here's how I achieve it. First, I define my function. Remember, we have to have that keyword def. I then define the function with the name gc underscore content. You don't have to have the same name as me, but don't put any spaces or anything in your name. And then the input it's going to take, I'm going to call seek. So the gc content function is going to take seek as an input. So the first thing I want to do is count the G occurrences. So I store seek.countG as a gcount variable, a variable called gcount. I then do seek.countC and store the result of that in a variable called seekcount. I also need to know how long my sequence is overall, my total sequence length. And remember, we have that len command, which I showed you before. So len of seek will be how many letters there are in my sequence overall. I then need to do total count equals the length of my sequence to store that length in a variable. So now I have the 3 variables I need to calculate GC content. I have the G count, the C count, and the total count. I then finally calculate a variable called GC content and set it equal to the G count plus the C count divided by the total count. And that's the variable that I'm going to return. So my output from my function is going to be GC content. My input is seek, and my output is GC content. Finally, you have to press enter one more time on that blank line and you should be able to run your function. Now I've been a little sneaky because when you run this function you might find you've got a problem. So if I run my function gccontent on this sequence here, which contains some g's and some c's, so we would expect a non-zero value, we get 0 back. So I'm running my gccontent function on this sequence and I would expect some value here, and my actual returned value is 0. So why does anyone think I'm getting 0 back here rather than a useful output? Any ideas? Only getting an integer number? Yeah. Exactly. So what we would expect back is some decimal, right? If you have 6 out of 10 of my sequence is G's or C's, you would expect 0.6 to be returned. But when we do this division of 6 divided by 10, the problem is that they are all integer numbers, they're all whole numbers, and we've seen previously when we did 5 divided by 2 that the decimal place information can be forgotten if both sides of the division sign are whole numbers. So I'm doing some whole number divided by another whole number. The answer is going to be less than 1 every time, and so I'm always getting 0 back. So how do we solve this problem? How do we make sure this gives us an actual result that we expect? Exactly. So we have to cast something here to a float. We have to convert some of these numbers, which are whole numbers, into numbers with decimal place information. So here's one example of what you might do. You can actually convert any of these things to a float as long as your division involves some float value. It should be good. So I apologize for making you retype everything, but it's good. It's a good lesson both on finger memory, but also on why sometimes you don't want to type large commands into the interactive environment, but you should be working in a text editor, as we will in a second. So you'll see that the code is exactly the same. The only difference now is that I've converted my G count to a float. You could convert the C count or the total count, whatever you want. As long as something in your division is a float, you should be good. Then when you run gccontent on your sequence, you should see a number returned that's actually a decimal number that is accurate. I encourage you to run it a few times on some different inputs and see the enrichment change. Hey.